Now we're going to talk about different relationships besides linear relationships in section 9.7. So now we're talking about inversely proportional relationships. Now, inversely proportional relationships are where as x increases, y decreases. So in a proportional relationship, as x increases, y increases too. For linear relationships whose graph have a negative slope, x increases, y decreases, but inversely proportional relationships are different than just having a negative slope. So we're not talking about just having a negative slope here. The product x, y is always going to be the same number. And so when we say x, y equals c, we can actually see that y equals c over x. This is not linear. So inverse proportional relationships are not just negative slope. They have a different kind of relationship. So let's look at an example of this just to kind of make sense of it. So we're going to consider these two relationships, and for them we're going to make a table, draw a graph, and write an equation. And I'm just going to double this in case I need more space. All right, and then write an equation explaining why we can write that relationship and what are they and what do they tell us. So relationship 1, a woman paints a fence at a steady rate. Initially, there are 200 feet of fence to paint. After 5 hours, the woman has finished painting the fence. Let x be the number of hours the woman has painted. Number of hours painted. And y is the number of feet left. That's important to paint. All right, so at the beginning, there are 200 feet left to paint. And how many hours has she painted? Well, it's initial, so at no hours. But after 5 hours, she finished. So how many is left to paint? Well, 0. Okay, so that's a table. Let's draw this graph. And again, we're talking about positive quantities, so we don't need to draw that x-axis. So this is our number of hours painted. And this is our number of feet left to paint. Now, that starts at 200, so maybe let's say like 50, 100, 150, 200. And then we could say 1, 2, 3, 4, 5. All right, so at 0, we start at 200. Maybe I'll use this here. And at 5, we're at 0. So here is the graph. So that is linear, okay? Also, it said steady rate. That was another clue for me. So here, what is our slope? You could use the formulas from the previous videos, or you could say, all right, remember that slope is rise over run. So we're going to start at this point. We rise by going down 200, and we're going to run to the right, so positive 5. So our slope is negative 40, and our y-intercept is 200. So our equation here is going to be y equals negative 40x plus 200. All right, and then let's look at relationship 2. Some men are painting a long fence. It takes 8 men 4 hours to paint the fence. Assume that all men work at the same steady rate. Let x be the number of men painting the fence, and let y be the number of hours it takes to paint the fence with that many men. So let's look at this, x and y. So x is the number of men, and y is the number of hours with that many men. Okay, so what do we know? Well, we know that with 8 men, it takes 4 hours. But if they're all working at the same rate, if I have double the amount of men, how many hours is that going to take? Well, if it takes them all the same rate, that if I use double the amount of men, it's going to be half the amount of time. Well, what if I go the other direction? If I use half the amount of men, it's going to be double the amount of time. What do you notice about these? They all equal the same value. This looks like an inversely proportional relationship where x, y equals 32, which is in fact our equation. We might even say y equals 32 over x. Well, we can graph this. So our x's go up to 16, so 2, 4, 6, 8, 10, 12, 14, 16. And this is our number of men. Oh, it's barely fitting. And then here, these are 2, 4, 6, 8. And these are the number of hours with that many men. Okay. So we've got 8 and 4, 16 and 2, and 4 and 8. This is what inversely proportional relations look like. Not quite linear. So what kind of relationships are these? Well, relationship 1 is linear, and this one is inversely proportional. And we could tell in a couple different ways. Looks like I didn't need that. And here it is written out for you. And let's look at another kind of relationship. So that was inversely proportional. Now let's talk about quadratic. So quadratic functions have these forms. Y equals ax squared plus bx plus c. A, b, and c are numbers. And a is not 0 because we want to keep that x squared. Otherwise, it'd just be linear if that was 0. So they don't have a constant rate of change, but they have some interesting patterns. They have a change in the change, and we're going to see that in the next slide. But they can model the height of an object falling. They're used a lot in physics and velocity. So this is the interesting pattern here. When we have a constant rate here, whatever that constant rate is here, the second difference, so 0 to 3 is 3, 3 to 8 is 5, but when we look at the difference between the differences, we get a constant second difference, and that is a quadratic function. Let's look at an example. Consider the function whose equation is y equals x squared minus 2x. Oh, and you know what? We need to grab a graph, so let me pull that from, let me find, where were we that we just had a graph? Okay. There we go. All right. So make a table in which, shows the inputs and the outputs. All right, let's make this a little bit smaller so I can draw my table. So I've got x and y equals x squared minus 2x. Now they gave me the inputs. So I'm going to input them. It's really important you use parentheses when you're dealing with quadratics because what's going to end up happening is that if you don't, you're going to get the wrong value. So I'm just plugging this in, just showing my work. Okay, and you get the idea. So when we get these, we end up getting 8, 3, and I encourage you to take out your calculator, pause the video, get these values all on your own. And then plot the points associated. So let's write them out. -2, 8, -1, 3, 0, 0, 1, -1, 3, 3. And again, do this on your own. And I just want to remind you here, -2 squared is equal to -2 times -2, and a negative times a negative is a positive, and that's why that's 4. But according to order of operations, this is, if you were to just type this in your calculator, what the calculator is going to do is exponent before multiplying by negative. So it's going to give you a -4, which is incorrect. So you always want to make sure you use a parenthesis because of order of operations. All right, so they want us to plot these. Now we do have negatives, so let's kind of go like this. And we'll go by 1 on the x-axis because those are going by 1s, but we'll go by 2s up here. So -1, -2, 2, 8, -1, 3, 0, 0, 1, -1. Oops, that would be -2. 3, so that's 1, 2, 3. 3, 3. Oh, I'm missing one. Look at that. 2, 0. There we go. 2, 0. And 4, 8. And we get this like nice mirror, and it will mirror around the vertex. And there we go. And there it is again. And so we are going to pause here, and hopefully we'll be able to finish the rest of the examples and the topics in the next video.